Hi, my name is Andrew Knight. This is a talk on the physics of consciousness, why mind uploading, brain copying, and conscious computers are impossible. This is new research and the proof of a new theorem that you have likely not seen before. This is a different approach to the physics of consciousness. I have another YouTube video on why computers will never be conscious. This is related only in the sense that the conclusions are sort of similar, but it's an entirely different approach, whereas the last video looked at consciousness from the perspective of special relativity. This will look at consciousness from the perspective of correlations to the underlying quantum events. I have a bachelor's degree and master's in nuclear engineering from University of Florida and MIT, as well as a law degree from Georgetown. This does not imply that what I'm about to say is correct, but that I hope I meet the minimum qualifications for at least putting forth the argument. The only similarity between this video and the previous one will be the following slide, which I'll discuss, but beyond that, everything else will be different. So let me start off with the problem, or the problems. So first of all, let's talk a little about physicalism, or materialism. That essentially says that everything we see, everything in the world, is a physical matter, and we can pose scientific, falsifiable hypotheses about the world and then test those. So we make the assumption that for any conscious state, I'm going to call it some conscious state 1, whatever that means, that it was created by or emerges from or depends on some underlying physical state, we'll call it S1. So in other words, it's not possible to experience a conscious state without some corresponding underlying physical state. And the reason I've put the asterisk here is just to say that this may actually be a set of possible physical states that all produce the same conscious state. I don't know, but it doesn't really make any difference in the progression of the argument. Now, another question is, well, what is a physical state that produces a conscious state? And what is a conscious state? Well, I don't really know, other than that I know that I am conscious right now. So whatever it is I'm experiencing right now, if we assume physicalism, then it must be the result of some underlying physical state. Well, what is that underlying physical state? Well, we might assume that it's the brain, but it might be more than that. It might be different. It might be my entire body, or it might be my environment or surroundings or the entire universe. I don't know, but what I do know, I think, is that the conscious state that I experience right now is the direct result of some underlying physical state. And that's kind of all we need to know in order to proceed with the following arguments. A mistake that is often made about physicalism is assuming that consciousness is algorithmic, that the brain is just a computer, and that ultimately consciousness can be created by or simulated by any general purpose computer. Now, it certainly seems like algorithms can happen in the brain. I can ask what is 3 times 4, and then I do the computation in my brain, and I can arrive at the correct computation. But that does not by itself imply that consciousness or even brain processes as a whole are fundamentally algorithmic. And in fact, many researchers, I think most famously Roger Penrose, the mathematician at Oxford, do not make this assumption and think that consciousness is in fact not algorithmic. Penrose gives a very interesting example. based on the Gödel incompleteness theorem, as to why consciousness cannot be algorithmic. But anyway, just realize that it is an assumption that consciousness is algorithmic, and that may not be true. The next assumption, the next mistake, is assuming that a conscious state can be copied or repeated. And maybe this may just be by copying a brain. If we can create an exact copy or duplicate of a brain, then maybe that produces the exact same conscious state, and so we can produce the same conscious state. Now again, this is an assumption within physicalism that is not required by or implied by physicalism. In fact, there are researchers who think that there is good reason to believe that conscious states cannot be copied. Scott Aronson, for example, is one of those, and I've mentioned one of those references at the end of this talk. And he suggests that, well, conscious states might not be copyable because if it turns out that to copy a conscious state, you have to make such a good copy of the underlying physical state that you violate the quantum non-cloning theorem, well, then that is good reason to believe within physics that you just won't be able to reproduce the same conscious state. So in any event, just recognize again that that is an assumption, and we have essentially no evidence at all, despite all of the research that has been done on brains and consciousness. We have essentially no evidence that a conscious state actually can be replicated. Another mistake that's often made is the assumption that quantum mechanics is essentially irrelevant to consciousness. And the argument goes something like this. Well, if the brain creates consciousness, the brain is this big, wet, hot mass, and it's a macroscopic system that would not probably be able to support quantum superpositions, and therefore, whatever consciousness arises from that physical brain, then it can be modeled classically. We really don't need quantum mechanics. And in fact, more importantly, quantum mechanics is just really irrelevant to consciousness. And I think this is a mistake, and I can give a counterexample very quickly. Imagine a person who's walking around a nuclear reactor with a Geiger counter, which is just designed so that whenever it detects an alpha particle from the decay of some unstable particle, like a uranium atom, then a series of multiplication or amplification processes happen that result in a click. So there is a measurement of some alpha decay, and then there's a click, and the person holding the Geiger counter then hears the click, which is to say the person then experiences a conscious state that is correlated to that radioactive decay. And of course, radioactive decay is quantum mechanical in nature, because in a 10-second period, did an atom decay or not? And that yes or no question is a quantum mechanical question. And therefore, that by itself is enough to show that sometimes conscious states do correlate to quantum events. And you might say, well, that's kind of that happens rarely. Well, you could set up an experiment so that a person's entire day consists of a whole bunch of clicks caused by quantum events, and we don't know how often quantum events correlate to our conscious experience on a day-to-day matter. But we can set it up so that it happens constantly. And then you might say, well, okay, but it's just a bunch of clicks, who really cares? Well, we can also set it up so that the detection of a decay causes the pressing of a big red button that causes World War III. Well, now that really has a huge effect on on the conscious states of lots and lots of people. So from that example alone, we know that consciousness must depend on quantum events, at least to some degree, and in fact, that's what this argument will depend on. So by making these mistakes, by assuming these aspects which are not required by physicalism, there are lots of very interesting, we can call them philosophical problems, problems of the philosophy of mind, but they're really physics problems because at some point, maybe now, they can be empirically tested, and that makes them scientific and physics questions. And one of those is the duplication teleportation problem. And Penrose mentions this in his book, what is it? The Emperor's New Mind. So imagine if I want to teleport myself to Mars. And the way we're going to do it is we set up some manufacturing facility on Mars, and then on Earth we scan the physical state that produces my conscious state. Again, we'll just assume for the moment that that is the brain. So we scan everything that is necessary to know about my brain, and then we send that information to the manufacturing facility on Mars, which then recreates my exact brain, and maybe my body and so forth, on Mars. Now, it's with different material, but it's the same physical state, we assume, and therefore it should be me. And then at the exact same time that I am created on Mars, somebody on Earth is then going to destroy this physical instantiation of me. And so the result should be the feeling of teleportation, that, at one moment I'm on Earth, and then I blink, and I find myself on Mars. But then what happens if the person who is responsible for killing this version on Earth just doesn't? What would that feel like if there are now two instances of me that could then diverge? I could have these different streams of consciousness. What would that feel like? And that seems to be a problem. Another problem is the simulation problem. So if consciousness is algorithmic, an algorithm is nothing more than a deterministic set of instructions, like software. So if consciousness is algorithmic, then that must mean that we should be able to copy a conscious state onto another computer. And the cost of copying software and running it on another computer is very, very low, especially when we consider the cost of creating an actual human who is actually experiencing a conscious state within this universe, right? That creates lots of matter and energy and so forth. So because it's so much easier to create copies of software, then the simulation argument is simply that it is essentially infinitely more likely that any given instantiation of a conscious state is a software, is a simulation, than that it's actually created by wetware, by an actual brain. And if that's true, then the likelihood that I am actually a simulation, I'm not really matter, I am actually one of thousands, millions, billions of simulations, that likelihood is essentially 100%. And that's kind of weird. And that depends on the assumption that conscious states are algorithmic and that they're copyable. Another problem is this notion of self-location. So Dr. Elga produced a paper asking what would happen if Dr. Evil tells you that you are, well, he doesn't tell you you're a simulation. He tells you that he has created 1,000 other simulations of you that he has access to, and he is going to torture all of them unless you give him $1 billion. And if it's true that this is possible, that conscious states can be copied, then you should take that threat very seriously, because you don't know when you hear that threat whether you're the real you or whether you're a simulation, i.e., you cannot locate yourself, the true self. So you should take that seriously and you should pay Dr. Evil. But if copying a conscious state is not possible, then this problem also goes away. And then another problem, and there's lots and lots of these kind of related problems. Just watch Black Mirror and you'll get an idea, or Doctor Who, you'll get an idea of all of the different possible weird consequences come from the possibility of copying conscious states. So another one of those is the Boltzmann brain, and it goes like this. So, okay, maybe we'll never be able to upload our awareness on a computer or to copy our brains, but the universe can. My brain, if consciousness is just the result of a brain state, my brain is just made of carbon and nitrogen and silicon and oxygen and lots of other stuff. And these atoms are floating out there in the universe. They just are. There aren't many of them in free space, but they're out there. And every once in a while, they'll bump into each other. And every once in a while, 3 of them will bump into each other. And every once in a while, 4 will bump into each other, and so forth. And given enough time, and by the way, it certainly seems like, based on cosmological evidence, that the universe probably is eternal in length. So given enough time, and eternity is enough time, enough of those atoms will come together in just the right way as to create my exact brain somewhere out in the universe. And so shouldn't that create my exact conscious state of me? And this could happen long after I'm dead and gone. So what would that feel like? And that seems to be another problem too, that depends on the possibility that conscious states can be recreated or reset or copied. I'm going to argue that all of these problems go away because these assumptions about physicalism are wrong. To start this, I'm going to give a thought experiment on how to win the lottery. The hard way, of course, is to actually just go buy a whole bunch of lottery tickets and to wait until the results come in and then just to hope that you won the lottery, but you will almost certainly be wrong every time. So what if you want to guarantee to win the lottery? Well, it's quite easy, right? I mean, if all of these assumptions about physicalism are true, then it should be very easy to win the lottery because all you have to do is just create the conscious state of you having won the lottery. So here's an example. So this little cloud represents your conscious state right now. And what you really want is to instantiate this conscious state of you having won the lottery. That's all you have to do. Maybe that just means creating the right brain or something bigger. We don't know, but let's just create that conscious state. Now, we don't just want to create that conscious state. In other words, you don't just want to believe momentarily that you've won the lottery and then wake up to reality and realize, crap, I didn't actually win the lottery. That would be probably worse than not thinking that you won the lottery at all. So really what you want is to create an adequate conscious state of winning such that all future possible evolutions, that's what I mean by these little apostrophes, these are just evolutions in time, and some of those evolutions might be deterministic by just Newtonian mechanics, and some may be the result of quantum events, but the point is we want to make sure that downstream conscious states are all consistent with this belief that you actually won the lottery. So you want it to be that tomorrow you experience a conscious state that you've won the lottery, and next week and next year and so on and so forth. You want to live for the rest of your life in a state that's consistent with the belief or the conscious state of having won the lottery in the first place. So how do you do that? Well, again, the natural way is to just choose the right numbers, and that's what this means right here, is that you've chosen the correct numbers that results in some conscious state. This conscious state, C right, just means that's the moment where you just realize that you actually have chosen all the right numbers, and then that will naturally evolve to this state in all future states. And I've left out, of course, lots of conscious states. I don't know how many are here, but the point is that it's somewhere between here and here, there has to be this conscious realization that you've won the lottery. At least this is kind of the natural progression. But the question I want to ask is there a wrong way to get there? In other words, so here's another possibility. So this is some possible path in which you've chosen the wrong numbers. And my question is there any way for that state to evolve to the one that we want to get to? And this is, of course, there's only essentially one right way to choose the lottery numbers, but there's, millions or billions. I don't know exactly how many. It depends on how many numbers are required for the lottery. But, there are potentially billions or even trillions of possible wrong ways to get there. So this is the conscious state of you realizing, oh crap, I chose the wrong numbers. But nevertheless, is it possible for it then to evolve to this conscious state in which you have won, and then every future conscious state is consistent with that belief? The question is this possible? Now, if it's true that you can create this C win, then that must mean that it is independent of the path that was taken. It's independent of the history that's taken, right? If at some earlier time we can guarantee that this will evolve or this can be created, then that must mean that this is actually independent of the path. And that's required because we want this to be able to result even if this wrong path is taken. Now, it may still be that this conscious state has a memory of choosing the right numbers. So maybe when you get here and here and here, you always have this memory of, I chose the right numbers. But that must be an illusion. If that's the case, it must be an illusion because, as we know, this is path independent, and therefore you could have gotten here by going this way, in which you've chosen the wrong number. So maybe this involves some sort of a memory modification. But ultimately, we know that this must be path independent. And so the question is, can a conscious state be independent of its preceding conscious states? And that's largely what this talk will be about. And then I'll explain, well, why does that even matter? And it turns out that there are very large, important implications that come from that. So in this talk, I'm going to try to show that conscious states are history dependent. And in this example, the one I just gave, I'm going to argue that the only way to get to conscious state C win, the one in which you believe and always continue to believe that you've won the lottery, that can only be reached via the path that involves the conscious state C right. That there isn't another conflicting path that could be taken. And if that's true, then embedded within the history of this conscious state is this state right here and every preceding state. So what I'm going to try to do is to argue for and prove the unique history theorem, which I'll clarify later. But essentially it says that every conscious state uniquely determines its history from a previous conscious state. And that's because every conscious state correlates to an underlying physical state that is itself history dependent. And that's part of what I'm about to show. Now, before I proceed, let me talk about the assumptions I'll make. I'm first going to assume that there is no free will. And I'll talk about this a little bit later because it's kind of odd. In quantum mechanics, it's kind of assumed that free will does exist in a weird way. So I'm going to simply assume that there is no free will. We've been debating this for centuries and millennia. It certainly feels like we have free will. I feel like I had the choice to make or to not make this video. But then again, it also seems like physics is either entirely deterministic, based on F equals ma and Newtonian mechanics, etc. And when it's not deterministic, it's because of some random quantum event. Well, random events don't give rise to free will. If they're just, if you're playing craps at the casino and you roll the dice, maybe the outcome of the dice is random, but that doesn't imply that you had free will to choose the results of that roll. So to simplify everything, I'm going to assume that there is no free will. As it turns out, and I won't prove that in this talk, but as it turns out, even if there is free will, the conclusion is the same. That is, the unique history theorem still holds. So if there's no free will, then any non-determinism in the universe must be because of some quantum mechanical branching. It's pretty simple. Now, speaking of quantum mechanics, there's a real problem. It's the measurement problem. And I won't get too deep into it, but essentially here's the problem. Quantum mechanics has been very, very good for the last century in making the right predictions about the world. It seems to be right. And what it seems to say is that any quantum system, which we usually think of as the state of a particle, but in principle it could be a larger system, a macroscopic system, the physical state of the entire universe. Any quantum mechanical system exists in a superposition of mutually exclusive states at the same time. So the spin of an electron is both up and down at the same time. Schrodinger's cat is both dead and alive at the same time, and so forth. So that's kind of premise A. Premise B is that when we observe the world, we observe outcomes. We observe an electron having a spin that is up or down. We never observe a superposition state. We observe Schrodinger's cat is, in fact, either dead or alive. We don't observe a superposition state. So the measurement problem has given rise to a variety of interpretations. Copenhagen just ignores it. Many Worlds says, well, they all exist at the same time. It has its own problems. There are some that say, well, there is an actual collapse of the wave state into one of these mutually exclusive possibilities. But that collapse is objective. It happens maybe, well, I won't get into it, GRW, orchestrated reduction. There's a lot of different ideas for this objective collapse of the wave state. And then some people say that, well, it's actually conscious observation that causes the collapse of the wave state. But that becomes problematic because does that mean if we're the only conscious civilization, does that mean that there is no reality in other parts of the universe because there's nothing conscious to collapse that wave state? There's a lot of problems. Right now, none of those interpretations are empirically distinct, which means right now, none of those interpretations are scientific. They're actually philosophy. So here's what I'm going to assume. Essentially what I'm going to do is I'm just going to ignore the problem, I think, as I should. And what I'm going to assume is this. I'm going to assume that by the time a conscious state correlates to some quantum event or some quantum outcome, that collapse or that reduction has already occurred. Now, maybe it occurred at the moment of that correlation, of that conscious observation, or maybe it occurred before. I don't know. But by the time I have experienced a conscious state that is correlated to some quantum event, then I know that that collapse has occurred. So that's the only assumption that I'll make about the measurement problem. So first I want to talk about why physical systems are history dependent. And what that means is that correlations continue to increase in physical states. Here's why. So imagine S is some physical state of some physical system. I don't know how big it is or how small. It doesn't matter. And then at some point, as it's evolving deterministically, at some point there arises a branching. So either event A or B can result. If it's event A, then it results in some state I'm gonna call it state sub A, and if it's event B, we're gonna call it some state SB. Now, what I've shown here is simply this SA to SA prime. I just mean that that's a later, that prime just means it's a later, it's the time evolution and it's deterministic. So at that point, then there could be another branching into options C and D. And then, of course, that could result then in these states. And the way I've written it is, for example, SAC means that state C is realized, event C happened, and notice that the possibility of C and D happening depended on the happening of, depended on the existence of this state, which depended on event A happening. So in other words, SAC really means that once C is realized, it also implies that A was realized. And then we can do this also for state SB. It evolves to some later time, and then there's some quantum branching resulting in possibilities E and F, and then that results in these states right here. And then we can take this further. So state AC can then evolve, and then it can have some further quantum branching, and so on and so forth. And we can see how this continues. Now, quantum mechanics says this. Which of these states actually happens? Well, many worlds says they all happen, but Copenhagen says, well, at some point there is a measurement. That's what this eyeball represents. And so let's say that, in fact, state, or we measure event E or some consequence of E. That is to say, maybe we're not measuring E directly, but event E causes other events that are correlated back to E. And the point is that it is observed directly or indirectly that event E happened. Well, what this tells us then is that because E happened, then state B, event B must have happened, and that must have resulted from this earlier state S, and which also resulted from earlier states, and so on. And so that means all other possibilities disappear. So once we've measured event E, or it's a consequence, then we know the history. We know what happened. Of course, we can ask, when did that collapse occur? Not going to go there. All I know is that by the time E is measured, the collapse of the reduction already has occurred. So let's consider a weird possibility, and this kind of gets back to the earlier lottery example, although now we're talking about physical states and not conscious states. So let's start with some physical state S that evolves deterministically until there's a quantum branching where events A or B could happen, and that would result in these states. My question is it possible for them both to evolve to the same physical state? We'll call it some S prime. And so somebody measures state S prime, and notice that S prime is uncorrelated to events A or B. It has to be, because if they both can evolve to the same state, then that must mean that there's no information in this physical state about whether A or B happened in the first place. So if it happens, so we say, well, we think that state A, there was a branching of state S into possible events A and B, but we actually measure downstream some state S prime that is uncorrelated to state A or B. What that really means is that we were wrong in saying that there was a quantum branching in the first place, that there never was such a state SA or state SB. And this is kind of counterintuitive, it's kind of weird. You can read about it. It's essentially a proof of it is the delayed choice quantum eraser experiment, which essentially says, I kind of almost don't want to paraphrase it. I'll try. Essentially, that if a quantum event does not result in a lasting physical correlation, then there was no quantum event in the first place. And I'm sure that I botched it. But there are lots of fascinating papers. This is just one. The Kim paper is just one example. There's lots of papers on this experiment. And what it essentially concludes is that quantum events result in physical correlations in the real world, in the physical state. So before I get to how this relates to conscious states, let me just pause briefly and talk about the weird relationship between free will and quantum mechanics. So note that when we did this, we talked about this experiment before where there's some quantum branching with possible outcomes A and B. Notice that whichever one actually results, it depends on a measurement, but the result, we don't know whether A or B is going to happen, and it depends on these amplitudes of these mutually exclusive states in the wave state. I've probably said too much, but the point is that the outcome that actually occurs is random. It's maybe 50-50, it may be 1%, 99%, but the point is that it's a random outcome. But that depends on the basis in which the state is measured. It depends on how it was measured. And for example, if we measure it in basis AB, which may be we're measuring whether the spin of an electron is up or down in the x dimension versus whether it's up or down in the y dimension. But to use normal English, let's say we're trying to see whether the electron is black or white, but we also could have asked whether the electron was red or blue. And so in other words, we can measure it in a different basis. And again, if we do that, the outcome itself is going to involve quantum randomness. We can't predict which one of those two outcomes actually obtains. But what does seem to be strange is that whether or not outcome A is possible versus outcome C is possible seems to depend on a free will choice of the basis of the measurement, of how the quantum state is measured in the first place. So whether or not the electron is white or red, whether those are possibilities seems to depend on free will. Now that's kind of weird. In fact, a lot of people, a lot of physicists don't even really internalize this conflict between quantum mechanics and free will, but that's a real problem. So in the rest of this talk, I'm going to make the simple assumption, not only, well, because there's no free will, I'm going to assume that there is no choice of basis at all, and rather that consciousness just arises from the underlying physical state. And I'll show you what I mean by that in the next slide. And again, I just want to point out that even though I'm assuming no free will, it turns out that even if there is free will, that the unique history theorem and all of its implications still follow. So now let's talk about quantum correlations in conscious states. So here's the nomenclature I'll use. So now this cloud represents the physical state S from which a conscious state C arises. So this creates this. And again, I don't know how big this is. Is this the brain? Is it the body? Is it something smaller? Is it the entire universe? I don't know. I'll talk about that later. But just in general, physicalism requires that this conscious state is purely physical and therefore has to be created by some underlying physical state. So now let's look at some quantum branching. So there's some quantum branching event that results in possible events A or B. And it turns out that state A does not change the conscious state. And state B doesn't change the conscious state. And that's not a problem because there are lots of quantum events we can imagine that don't instantly cause a correlation to the resulting conscious state. So again, there's some evolution, some time evolution to some later conscious state, and then there's some branching then that results in some new physical states that cause other conscious states. And in this example, I've shown it where SAC creates conscious state CAC, and SAD creates conscious state C. And so what that means is that for whatever reason, if event C obtains, then the resulting conscious state does correlate to C. And if D obtains, then for some reason, the resulting conscious state does not correlate. These are just examples, just to explain the nomenclature. It could be different. And same for B. The same sorts of things could happen. And then we can continue as before, where each of these states then can evolve deterministically until there's more branching, and then that produces other physical states, and some of those states get instantly correlated in their conscious states and some don't, and so on. Now, in this example, because I've forgotten, there is no free will, there's no measurement problem here, there's no choice of bases to measure. All we know, or all I know, is that I do experience conscious states. And so let's say that let's say you find yourself in conscious state C. Now, notice that that corresponds to potentially lots of underlying physical states. So that doesn't necessarily say what your physical state is. But if you find yourself in some conscious state that's correlated to state or to event E, which is right there, then now you do know the physical state, the underlying physical state, and also what its physical history was, and every other possibility goes away. So what I want to know is whether conscious states determine their histories. So to do so, I'm actually going to look, now let's look at this particular conscious state and its possible future evolution. We'll do that on the next slide. So let's say that, and now I'm going to forget about the kind of time evolution, because I just want to talk about quantum branchings. So let's say at some point there is some quantum event where possible outcomes are I and J, and those would result in these possible states. And let's just say that this state would produce a conscious state that is correlated to I, and this physical state would produce a conscious state that is correlated to J. What I want to know is it possible for these different conscious states to then evolve to the same conscious state that is not correlated to this event in the first place? And by the way, I've been very vague about what I mean by correlation, especially a conscious correlation, and I feel like I'll talk about that a little bit more. But it doesn't necessarily mean that the person directly measured event I or knows that quantum event I happened or whatever. It just means that this conscious state couldn't have happened unless this happened. This conscious state depends on the happening of this state. That something downwind from this event creates a conscious state that can be traced back to the happening of this event. So could they merge into the same state? Okay, so before I get there, imagine, of course, that these are possible branchings and evolutions from that state, and then these are possible branchings and evolutions from that lower state. So notice that when event R happens, of course, the underlying physical state is correlated with R, which has to be the case because that's what it means for this quantum event to happen, is that it gets correlated in the physical state. But maybe the resulting conscious state is not correlated to R, and notice it's not even correlated to I. And the same here, this conscious state is not correlated to S or to J, and so that these are the same conscious states. Is that possible? And so the question is, are these different paths, the ones that follow this versus this path, are these different paths, are those possible evolutions of conscious states? And if so, what would that feel like? So to discuss that, I'm going to give a thought experiment about the quantum taxpayer. So let's say that there's some glitch in an IRS computer that has the effect that there's some quantum event that happens in the computer, and the result is that quantum event or quantum outcome A results in a refund check of $1,000 being sent to Bob the taxpayer, whereas the outcome B results in a threatening letter with a demand for $1,000, and that is mailed to Bob. So, of course, when he first gets the letter, his conscious state immediately becomes correlated to either A or B. So maybe that first conscious state, conscious state A, is when it first finally sinks in. He's holding that it first finally sinks in that, wow, I'm $1,000 richer. And then conscious state B is that first realization in which he realizes, crap, I got to write a big check and I don't have the money and I'm in big trouble and I'm going to get audited and whatever. So let's consider now some possible conscious experiences that result from that. So this is his stream of consciousness. And of course, by stream of consciousness, I mean it only in the colloquial sense. I don't know whether there is such a thing. I don't know whether conscious states are continuous or whether they're discrete, or I don't know, but I just kind of use this in the general sense. So this is his state right before he gets the letter, and these are the possible outcomes of that quantum mechanical event. Now let's consider conscious state A, where he first realizes his windfall. And one possible result is that he excitedly calls his mother to tell her about this extra money. And the reason I've written it with this dotted line here is because I'm being very crude here. This is probably not his next conscious state. There are probably lots and lots of conscious states between CA and this conscious state. And there may be lots of even quantum branchings between here. So as he goes to reach for his phone to call his mother, one event, for some reason, gets amplified so that he drops his phone, and another one doesn't. My point is, this is certainly a possible future conscious state from CA. And then we can imagine some possible evolution of those conscious states. After that, he drives to the bank and he's really excited and he speeds to the bank, and on the way he causes a big car accident. He gets sued for millions of dollars. His insurance isn't enough to cover it. He loses his house and his money and his assets. And then, he's very sad, and so he starts writing country music. And he's very good at it, so eventually he starts to win Grammys. So that's one possible evolution. And now let's consider the same thing for if event B had happened. He realizes his loss and he shouts angrily at the gods, and he then punches a hole in the wall and kicks the wall and then realizes, oh wait, there's something behind the wall. It looks like this antique container, and so he opens up the wall and opens the container and sees a whole bunch of bricks of solid gold and other treasures. And then he invests all of that money into space tourism and then ends up owning a whole bunch of rockets and so forth. And then he blasts himself to Mars because he wants to go to Mars. And along the way, he realizes he hasn't protected for radiation in space, and so he starts throwing up from acute radiation sickness. So these are just some possible streams that he could experience from these two events. And the question is it possible, is it conceivable that they could ever evolve to the same conscious state? That is, a state that is completely uncorrelated to those original events. So we want to know whether it's possible for them to evolve to the same conscious state that is uncorrelated to those original events, to that original quantum branching. And of course, remember that correlation does not necessarily imply memory. It may very well be that this is, 20 years after the original event, and he may not even remember that letter, may not even recall that this was the thing that caused him to, or was one of the causing events of him winning Grammys. But that's not the question. He doesn't just have to remember it or know that it happens. This is simply the notion that this conscious state correlates to this event. That is, that this could not have happened. That is, this is downstream of this event. And so the question is there any conscious state along here that is not correlated to this original event? And there's a very, very good movie on this, Sliding Doors, which is kind of a similar idea. There was, well, you can watch the movie, but essentially there's some little event, whether or not she makes it into the subway, whether or not the doors close in front of her or behind her, that then result in these completely different possible paths. And the question is, could those paths ever evolve into the same conscious state? And I think it's kind of obvious from, I think it's kind of clear that, no, it probably isn't possible. It doesn't really make sense that they could ever evolve to the exact same conscious state. But that's exactly what I want to prove. And this was just the example to put you in the right mindset. So let's go back to the earlier example in which I have posited the existence of these two physical states that give rise to the same conscious states that are uncorrelated to previous quantum events. So let's analyze it a little bit further. So remember, of course, that the predecessor to this event was these physical states, and it didn't change the conscious state. In all cases, for some reason, measuring event D, or not measuring, but rather the physical state collapsing into or resulting in state or event D did not immediately correlate into the resultant conscious state. So the conscious state doesn't change here, even though quantum events are occurring along here. So then after this, we can imagine each of these individual states then evolving in their own way. And I've only shown one possible branching, but of course these could potentially branch and so on and so forth. But I only have space to show the branching of these two. So note that conscious state CAD does not uniquely determine its history, because if you're in conscious state CAD, then you don't know whether the preceding state was this one or this one. So it does not uniquely determine its history, and we want to see whether or not that's possible. So notice it doesn't, but that every other conscious state here does uniquely determine its state. So for example, this one, once you're in this conscious state right here, it is correlated to event X. And once you know you're correlated to event X, then that underlying physical state determines its history, and each one of those physical states then determine the resulting conscious state. So we're going to now just analyze whether or not this is a possibility. And we're going to do it by considering the stream of consciousness of the person experiencing this, this physical evolution. Let's consider that subjective experience. And I've just written it out here. This is the same thing as appeared in the last slide, but just shown in a single line. So possibility one is that for whatever reason, one's stream of consciousness just skips over some immediately forgotten state. So in other words, there's this conscious state C, But if this future conscious state right here is not correlated to event I, then it must be that I is immediately forgotten. And so what happens is that there's just a skipping over from here to here, then to here. And so the experience is just this. And so in that case, conscious state CAD does uniquely determine its history. There's no problem here because the history is clear. The history before that is C, and then of course whatever previous experience, previous history from that. Possibility 2 is stream of consciousness is subjectively experienced in the order of increasing correlations. So maybe weirdness happens in the underlying physical state of the universe, but consciously we only experience increasing correlations. And there's arguments in thermodynamics, the thermodynamic arrow of time, that may lend credence to this possibility. And so even though the physical system evolves in this way, what's actually experienced is this right here, where CAD is experienced before this. Well, again, there's no problem now, and so CAD does uniquely determine its history. And again, this is what I'm trying to prove. I'm trying to prove that every conscious state uniquely determines its history by pointing out a situation where it seems not to, and then analyzing it. So CAD seems not to, but here's a case where if consciousness is subjectively experienced in this order, well, then there's no problem. So possibility 3 is really the problem, and that is where the subjective experience is just in line with the physical evolution of the universe, and so this is what's experienced. And so what does that even mean? What does it mean to experience this state? So, the person experiences some conscious state C, then right after that, CADI, which is correlated to event I, and then immediately forgets event I, or even if it's not event I, it's some event that is correlated to event I, so immediately forgets that state and goes into state CAD, but then immediately after that goes into this state right here, which not only is correlated to X, but is also therefore correlated to I. So you go from a conscious state C, then to one that is correlated to I, then is not, and then is. And the question is this possible? To analyze that, I'm going to introduce this notion of lag in conscious correlation. And that's just the number of measurement outcomes to which an underlying physical state is correlated, but the resulting conscious state is not. So, for example, this is the example from the last slide. Notice that this state S produces state C, and so there's no lag here. And then this state SA produces the same state, so now lag has increased by 1. So the state, physical state, has evolved into the next state. There is a correlation to an underlying quantum event, but the resulting conscious state did not so correlate, so lag increases by 1. And here's a case where the underlying state correlates to D, but the resulting conscious state does not, so lag increases again by 1. And then now, conscious state, whenever event I happens, the resulting physical state then does produce a conscious state that is correlated to that event I. So it's like lag gets zeroed out. So the conscious state caught up with the underlying physical state. But now in the next state, we see that lag has jumped up by not 1, but by 2. And then in the next state after that, the conscious state catches up to the underlying physical state, so the lag goes back to 0. So the problem with CAD, notice, is this lag that jumps from 0 to 2. And the question is such a lag increase possible? And I argue it's not. is this kind of unnatural lag possible? First of all, let me say I don't know for certain. These are just arguments. I think it's physically impossible, but we'll see. One argument is this. Well, if lag is just represented by the number n, and the underlying physical state S changes, the question is, did the resulting conscious state change? Well, if it did, then that means that either lag stayed the same or lag went down. So if there is a change to the physical state that results in a change to the resulting conscious state, then lag did not increase. So if that's not the case, then lag goes up by 1. So if there's a physical state change by 1 quantum event, and consciousness does not catch up, then that must mean that lag increases by 1. So how could it be physically possible for lag ever to increase by 2 or more in a single step? So that's one argument, that it's not possible. The next argument is this. Again, I have assumed no free will. You can't choose, therefore, when your conscious state correlates to some underlying physical event, some underlying quantum event. You can't choose that. It just so happens, for whatever reason, the universe is such that an underlying physical state creates some conscious state. The conscious state I'm in right now is created by some underlying physical state, and I can't choose whether or not to correlate my current conscious state with some quantum event that has happened in that underlying physical state. It's just gonna happen. So if that's true, then it also means that the universe, or the laws of physics, however you want to think of it, also determine lag. And why the hell would the universe care about when I happen to perceive something? Why would the universe have it such that I would be consciously correlated to event I now, but then in the next conscious state not be correlated to I, and then the next conscious state after that to be correlated to I? Why would the universe care about my observation, especially since I've assumed not only is there no free will, I've also assumed that consciousness doesn't cause anything quantum mechanical. It doesn't cause the collapse of the wave state. So that would be odd. But then another problem is this. I've assumed that this is possible. Some CAD is possible in the previous examples, so that two mutually exclusive physical states could evolve to this state. So therefore, I've assumed that this state does not uniquely determine its history. Because if it did determine its history, then we would know which path was taken to get to it, and then we're done. We've proven the unique history theorem. So we've assumed that it's history independent. Therefore, at the moment that it is experienced, then there is no fact about whether or not event I or J has happened. There is no fact about whether there is some previously experienced conscious state that was correlated to events I or J. But the problem with this is that in the last example, this is only produced by this state or this state. But let's say it's produced by this state. So I'm experiencing conscious state CAD that is produced by this. Well, this means that the preceding conscious state was CADI and not CADJ, and therefore this must embed the history of that earlier conscious state. And another way to say it is, once you're in this conscious state that results from this physical state, the next conscious state or some future conscious state eventually is going to correlate to I. So being in this, there isn't just one state CAD. There's two. There's one that eventually will correlate to event I, and there's one that will eventually correlate to event J, which just means that we were wrong in saying that this was history independent in the first place, and therefore that previous example isn't possible. Nevertheless, even if that doesn't convince you, even if lag might still be a problem, we can certainly ask the question, well, how big a problem is lag? And what the heck is lag in the first place? It's this kind of this difference between quantum correlations in the underlying physical state and how long they take to correlate to the resulting conscious states. But this video is streaming to you at, I think, 30 frames per second. And the reason that number is chosen is because it was found that if you stream it at 10 or 15 frames a second, you'll notice, consciously you will notice. So that must mean that, I don't know, that seems to imply to me that in general, conscious lags may be on the order of fractions of a second. They may be really insignificant if you can consciously distinguish between states and lags that are a 30th or a 15th of a second different. So now we get to the unique history theorem. And so what I'll say is this. Again, because I don't know for certain about whether or not unnatural lag is possible, I'll just simply say this. For any time period in which lag is insignificant, and most of the time that's going to be the case because the unique history theorem has implications over the long run. You know, does my current conscious state uniquely determine its history from a conscious state I experienced last year or 10 years ago? Versus, does it uniquely determine its history from a conscious state I experienced a second ago? Well, I don't really care about that so much. So I'm going to say that in general, lag is insignificant, and certainly for any time period in which lag is significant, then a unique stream of consciousness maps some conscious state to some possible future conscious state. And another way of saying that is that every conscious state uniquely determines its history from an earlier conscious state. I've taken an hour to show this. Why does this even matter? Why does this make any difference at all? And here's why. The potential implications are huge. One of them is that you can't repeat or reset a conscious state. It doesn't make any difference how the conscious state is created, what underlying physical state created that conscious state. A conscious state cannot be repeat or reset. And the example here is just very simple. It just says, the unique history theorem applies to state C2, but what is its history? Is it 1, 2, 3, or is it just 1? So this violates the unique history theorem. Another implication is that you can't copy a conscious state. And you can't create some conscious state de novo from scratch. I can't just create my same conscious state with some other matter elsewhere, and I can't copy my current conscious state independently of what we think about its underlying physical state. I've just shown, if the unique history theorem is correct, that you just can't copy a conscious state and you can't create one from scratch. And the reason is, if you could, they wouldn't have the right history. They would be history independent. They wouldn't have the requisite history, so you can't do it. And then kind of a corollary is, well, if the brain is what causes consciousness, then brain copying is just impossible. Another consequence is that algorithms and software, again, are just deterministic sets of instructions, and you can write them out, and then you can store them on a digital computer in the form of ones and zeros corresponding to ons and offs of transistors, etc. And they can be easily copied and run and executed on other computers. And in fact, the software that I run on this computer, the execution should be identical to that same software run on a different computer 1,000 light years from here, made of Tinker Toys. It shouldn't make any difference as to the execution of that software. So if that's true, well, we already know that a conscious state can't be repeated or copied, and so that must mean that consciousness itself cannot be software. It cannot be just a deterministic set of instructions. Therefore, consciousness is not algorithmic. Therefore, computers will never be conscious. Therefore, you cannot upload your mind to a computer. And on the good side, I don't necessarily say that these are the previous ones are bad implications, but certainly a good implication is that these philosophy of mind problems that I mentioned earlier, and lots of other weird problems that result from the copying of conscious states, just disappear. They no longer are problems anymore. But I think the biggest implication of the unique history theorem, if it's right, is this. Fundamentally, as a society, we're barking up the wrong tree. We're going down the wrong path. We're spending a lot of time thinking about, and not just in science fiction and movies and stories and so forth, but even in the real research we're doing, we're spending a lot of time thinking about and working on mind uploading, creating conscious artificial intelligence, or worrying about conscious artificial intelligence, creating digital copies of the human brain, copying ourselves in general, teleporting ourselves to another planet by scanning the brain and creating a corresponding brain in a vat on Mars or some other planet in a different galaxy. It turns out that these may all be impossible physically, and that we're just going down the wrong path. Now, having said all that, I want to address some objections and questions to the unique history theorem. So the first objection I want to address is one posed by Scott Aronson, who is referenced later. It's a very good objection. And it's basically that, well, didn't I just assume basically that some physical state that creates consciousness exceeds the brain? I've assumed that the brain does not by itself create consciousness. And the reason the way I've assumed that is in this example before, where I said, there's some underlying physical state that creates a conscious state. Then there's some quantum event here. Now, that certainly could have happened, we presume, within the brain. But then there are real debates and doubts as to whether quantum superpositions could even be sustained in the brain. So, but in any event, it doesn't matter. I already gave an example where there are certainly quantum events that happen outside the brain that then can result in correlated conscious states. So whether I measure the spin of an electron to be up or down, I see the result on the measuring device, and that results in a correlated conscious state. So the question is, didn't I already assume that if the conscious state depended on that underlying physical state that included some external quantum event outside the brain, then I've already assumed that consciousness exceeds the brain? And so why don't I instead think of everything this way? So I'm going to think of some larger physical system, and that could now include, the laboratory, or maybe the entire Earth, or maybe even the entire universe, and then think of some underlying state of the brain, SB, that then produces the conscious state. And then when there is some quantum event outside of the brain, in the external world, that results in a correlated state A or state B of the universe or the Earth or whatever. And then that results in a correlated state of the brain that then results in a correlated conscious state. So why isn't this the correct picture? And if so, then what we'll do is we will just look at this particular brain, and we'll recreate this particular brain somewhere else, right? We'll copy this exact brain somewhere else. And so, so now, we have this physical state of the brain, physical state A of the brain that causes the conscious state A. What's wrong with this? Why can't we just make another copy of this somewhere else in the universe? What's the problem there? Well, the problem is this. If we say that this conscious state A is distinct from this other conscious state B, and it is because it was in fact experienced, then if this conscious state A is experienced and it's correlated then to this event A here, the question is, well, how is it that it's correlated to or entangled with or evidence of some event A, but there is no event A in this case? In this copy, there is no event that distinguishes these two possible conscious and physical states. So I think this is the first time in the talk where I've mentioned the word entanglement. Correlation and entanglement are in a lot of ways the same thing, but I didn't want to use the word entanglement because you may already know there's all kinds of issues with when two particles are entangled, then they can be separated by any distance, and if one is measured in some basis, and then the other particle is measured in the same basis, then the outcomes will always be correlated. Either they'll be the same or they'll be exactly opposite or whatever, but they'll always be correlated no matter how far apart they are. And even though individually the outcomes look random, and that's a problem because it seems like the only way to do that is to send information from one to the other instantaneously. That is to break special relativity because it's going faster than the speed of light. But then also this notion of which one would send the other information, because if they're space-like separated, then there is no notion of which one comes first. There is no notion of simultaneity. So anyway, spooky action at a distance, as Einstein liked to call it, still has not been solved in a logical or philosophical sense. So that's the reason I didn't use the word entanglement. But I do think this implies that part of what makes the copying of conscious states impossible is that that physical state that produces that conscious state has entanglements, correlations to physical events or quantum events that are external to the brain. And those events could have happened, very far away, at a very, very long distance away from me in space-time. And yet, the fact that a conscious state is distinct from another conscious state depends on that quantum branching that could have happened external to the brain. So in other words, this is weird, and this is an interesting objection, but I don't think that that my proof assumed that the physical state that creates consciousness exceeds the brain. I think that's the result of the proof. I think that I have then, that one of the implications then of this proof is that, in fact, consciousness depends on a physical state that exceeds the brain. It's not to say that the brain and consciousness are unrelated. Of course they're related, right? But it does suggest that even if there were some way to copy a brain in a way that didn't violate the no cloning theorem, that still would not be sufficient to reproduce the same conscious state. So other objections are, well, the definition of conscious or stream of consciousness. Again, stream of consciousness, I don't know. I was just representing it in terms of different conscious states. They could be continuous or discrete, I don't know. But as far as conscious, a lot of people want to get hung up on, well, you have to define the word and nobody knows what that means, etc. No, I know that I'm conscious right now. I know that I'm in a conscious state right now. I don't know what that means, but I know that I'm conscious. And I know that if materialism is correct, then that is created by some underlying physical state. And that's all I need to get to where I'm at. Another objection is one that I hear from philosophers, and it's this notion that, well, you don't know that if you copy somebody's brain or you copy their conscious state, that you're creating the same person. That is, they're not numerically identical. But that's not a problem, because remember all of the problems that I mentioned earlier, the notion of I'm going to teleport myself by recreating my conscious state on Mars and then killing this instantiation, and therefore that depended on the notion that creating that same physical state that results in that same conscious state creates me. If it didn't create me, then the problem goes away. And it's the same with the simulation problem. If all of those different copies didn't produce me, then I'm not worried about being a simulation, because I know I have to be the real one. And so basically all these problems go away if it's not the case that the same physical state will produce the same conscious state of the same person. Another objection, isn't this just a simplistic view of reality? I mean, I have this notion of binary quantum events. I mean, quantum events are almost certainly never, or very rarely, binary. In fact, the simplest, maybe not the simplest, but the most common example of a quantum mechanical state is the position of a particle. And the way that's represented is essentially in an infinite dimensional space where the particle has some likelihood of being over there, and some likelihood of being here, and some likelihood of being here, and so forth. And we can say, well, the particle's in a wave packet, so that it's really likely to be in some localized area, but there's still some possibility that it could be measured 1,000 light years from here. And so infinite dimensional is far more complicated than a two-dimensional wave state. And that's true, but that doesn't mean that this argumentation is wrong. And further, it also means that I have a long way to go in this research. This is just the beginning of my research, and I really want to connect with people who are thinking about these problems, and I would really love to hear your comments and thoughts and objections, because I want to continue to improve on this line of reasoning. Another objection is, well, why use physics? I mean, of the people who are thinking academically about consciousness, of the people who are thinking scientifically about consciousness, the vast majority of them, setting aside Penrose and a few others, the vast majority of them are looking at it from the perspective of neurobiology. They're looking at the brain. And we have made huge progress in figuring out where certain neural connections happen and what the results are and so forth. But it's very complicated to look at the brain and slice it up in terms of the 100 billion neurons that it encompasses. And I think that if we can come to any conclusions from the fundamental physical standpoint, then great. Then that certainly is the path that I want to take, because if biology is the approximation of the underlying chemistry involved, and chemistry is the approximation of the underlying physics involved, then what I'd like to do is to start with the physics and see what I can figure out from there. And that means considering classical mechanics and quantum mechanics and special relativity and so forth, and seeing, can we figure out things about consciousness from a physics standpoint? And if so, that's where I'd like to go with this. Another objection, isn't this just philosophy at best, or at worst it's just pseudoscience? And I'm sure that's what some people will say. We'll just dismiss it as this is pseudoscience. I'm not sure what would make it pseudoscience. Everything that I've said up until now has been based on looking at consciousness from a purely physics standpoint. And in fact, I think to assert that consciousness must be a physical phenomenon, and then to ask what the consequences of the laws of physics would be on consciousness, makes it a scientific question. But maybe it's just philosophy, not to denigrate philosophy, but I think we're at a stage in technology where these big questions of the relationship between mind and matter are becoming empirical questions. We can create falsifiable hypotheses about the nature of consciousness, and I think that makes them scientific questions and not philosophy questions. But my favorite objection is this. I mean, come on. I mean, I hope you have found this talk to be interesting, but let's get real. We already know the brain is just a computer. We already know that it's just a matter of time before we can upload our minds and before we can copy brains and create duplication. We already know these things, right? Well, the answer is no, we don't know these at all. Actually, while we have made huge progress in neurobiology and understanding the brain, we're still at the very tip of the iceberg. If scientists are honest, and many of them are about this issue, they will admit that we still don't know very much about the workings of the brain, and certainly how it might create consciousness. And we have essentially no evidence that the brain is algorithmic. We know that it has all kinds of parallel processing, and that a neuron is nothing like a transistor. A neuron has, 6 or 10,000 connections, whereas a transistor of a digital computer has just, 3 connections. And so we actually have very good evidence that the brain is not a digital computer. So I've given, I think, strong scientific arguments as to why a conscious state cannot be copied and why it is not algorithmic. And there's very little scientific evidence that consciousness is algorithmic or that the brain is a computer. So I think that this conclusion that conscious states really cannot be copied really should be taken seriously. And then I would love to hear other objections and other thoughts that you have, as well as questions you have. And then finally, here's a list of a few references that I mentioned earlier in the talk. And on that note, thank you for listening, and that's it.